User authentication is hard. Practically every type of application will need it one way or another, but there's a lot of different ways to do it. You can easily spend weeks comparing different authentication strategies, service providers, and seeing how it fits with your application design. Which is why in this video, I'm going to save you the effort by recommending that you use Firebase Authentication. It's reliable since it's backed by Google, it's widely used, it's free, and it will most likely fit your use case. And even if it doesn't, you'll still be able to generalize the things you'll learn in this tutorial and apply them to a different technology. The same goes for the front end and the backend components of this project, NextJS and Python FastAPI respectively. I've chosen them for this tutorial because they are my preferred framework, but if they're not for you, then you should be able to generalize the contents of this tutorial to the framework of your choice. First, let's take a look at what we'll build by the end of this video. Our front end is a fake e-commerce website built with Next.js. I can click this button to sign in with my Google account. Once signed in, I'll be redirected to this dashboard where I can see my username. I can click this button to send a request to a fake API endpoint that I've set up. My request to the API will have the authorization token in its HTTP header. This will contain my user ID and cryptographic proof that I am authorized to do this action. This token is ultimately how the API can decide whether or not this is a real request and what information it should have access to. Finally, there's a sign out button that I can click to sign myself out. When I'm signed out, I can no longer access the dashboard. It'll just keep redirecting me back to the login page. To code along with this project, you will need a Node.js runtime and the npm command that comes along with it. You can check your versions by typing node-version and npm-version respectively. I'm using Node version 16 and npm version 7. If you don't have these, then I recommend using a Node version manager or NVM to install them. I also recommend having a bit of experience working with Next.js or at least React in TypeScript. Otherwise, check out the links in the video description for resources on how to get started. We'll be using a project template I've prepared earlier, which you can clone from GitHub. It's a fake e-commerce store with a login page and a dashboard, and our goal is to add user authentication to it. For the backend API, you don't have to do anything. I've already prepared a public API endpoint that you can use to test your requests and check if your authentication token is attached properly and if it is valid. The backend API, by the way, is implemented in Python using FastAPI and is hosted on AWS Lambda. The source code is in the comments. And if you're interested in how to set up something like that, then feel free to check out my other video tutorial on that topic. Let's start off by cloning the template project that I've prepared. The GitHub repository is called NextJS shop template, and you can find it in the video comments. You can just clone it to get started, or because I've marked this project as a template, you can actually click use this template to create a brand new repository from it. Now you go into the project directory and there should be a subdirectory called site. Go in there as well. Install the project dependencies by running npm install. When that's done, you should be able to test the site locally by running npm run dev. And if you go to this URL, usually localhost 3000, you should see the site template. On the index page, there's a button to sign in. If you click it, it takes you to a dashboard page where a couple of fake items are displayed. There's a status bar that should display the user information and a sign out button that takes us back to the index. In the lowest section of the page, there's a button to add item, which doesn't do anything right now. So as you can see, the entire site is all for show. None of the things work. Our objective for this project is to wire all of this up with user authentication. That includes signing in and out, automatic routing, and attaching an authentication token to our outbound API request. First, we need to set up a Firebase project so that we can use its authentication service. Go to firebase.google.com. You can sign in with your Google account or create one if you don't have one already, and then go to the console. Click here to create a Firebase project. A project is Firebase's way of organizing a group of services and resources that you want to use together. For example, databases, storage, and authentication. Enter a name for your project. I'm going to call this one Pixegami Online Store. And then click Create and wait for the project to be ready. When the project is ready, you'll see this very nice dashboard. Now we'll have to add our Firebase to our Next.js app. As you can see, Firebase has many different integrations, including mobile and Unity apps as well. But today our app is Next.js, so we'll just click on this web app. A project can have multiple apps. So now we'll register a new app to this project. And since I'm just planning to use Firebase for authentication, I'm not going to add any hosting. Click Register App, and once that's done, there's some instructions on how we can install and configure the Firebase SDK in our NextJS project so that we can use Firebase there. So let's follow those instructions. Back in our project console, run npm install Firebase. When that's finished, go back to your browser and copy the rest of the configuration script. We'll have to put this in our project somewhere. I'm going to open up the project in VS Code, and let's create a new folder called Firebase to store on configuration. In the folder, we'll create a file called firebaseapp.ts and just paste that configuration we copied from the browser. Now this app object we create will initialize the Firebase client, but in Next.js or React, we'll actually have to import this app for it to have any effect. So from this file, I'm going to export this app so we have the ability to import it from our other pages. And in fact, to make it more explicit that I want to initialize Firebase from my other pages, I'm actually going to export a function called init_firebase that actually returns the initialized app. That way it's clear that when we use this function, our intent is to initialize the SDK, whether or not we actually want to use the client. Now on the index.tsx page of my project, I can initialize Firebase by using my exported function. And if I console log the result, I should be able to see the Firebase client object. So now our Firebase client has been successfully configured in our Next.js app. Once Firebase has been set up, adding authentication to our site is easy. Let's go back to the Firebase dashboard here and click Continue to Console. Then click on Authentication. There's a lot of helpful guides and videos on this page if you want to read more about it. Otherwise, click on Get Started. Firebase has many integrations with third-party auth providers that we can choose from. Our users can just log in with an account they already have, for example, like with Google or Facebook. I actually like using this rather than having our own email password system because customers don't have to create a new account for our site. But you can also do that if you really wanted to. Today though, I'm just going to turn on Google Authentication Provider. Just follow the prompts to get it all set up. You can leave most of the settings as default. When you're done, Firebase will take you back to the authentication dashboard, which currently has 0 users. Now we have to figure out how to add this Google sign-in to our project. Let's go to the documentation. Click on Build, then Authentication. Then go to Web and Google. These steps will help us add Google Authentication to the app. We've actually already done the first couple of steps, so let's skip down to the code examples. We can either embed a sign-in page to our site or do it with a pop-up. So I'm going to do it with a pop-up. This snippet here shows us exactly how to do that, so let's add it to our project. Let's go back to our index page in VS Code, import getAuth, sign-in with pop-up, and the Google Auth provider from Firebase/auth at the top of your file. Then create an instance of the Google Auth provider and an instance of the Firebase Auth client. I'm going to create an async function called sign_in, and it's going to call this sign_in with pop-up function that we imported from Firebase with the auth client and the Google provider as its arguments. We'll await the results of the sign-in and log the user object when it's done. I'll later wire up to my sign-in button. Now if we go back to the site, you should be able to log in with this pop-up. And in the console, you will be able to see your user's display name and email. And because this is a new user to our Firebase project, if we go to the authentication console and refresh it, we'll see our new user has been added. This user UID is also generated for us, and it's what we can later use to identify our user from the backend API. Now that the user is able to log in, let's do something useful with that information. If they are logged in, I want to redirect them to the dashboard. Firebase provides us with a callback function that is triggered by state changes in user authentication. But in a Next.js or a React project, I think it feels a little bit clunky to use because it doesn't really fit with our state hooks paradigm, and we'll also have to write a bunch of boilerplate code to persist that state between pages. Instead of implementing that ourselves, we'll use another library called React Firebase Hooks to solve this problem for us. This will give us some nice abstractions. Install it in the project by running npm install react firebase hooks. After it's installed, go back to our index page and import useAuth state from react firebase hooks/auth. Now I can use this hook to immediately get the user state, and there's also a loading Boolean state that I can use to know whether or not I need to wait for it to load. If it's still loading, I'm just going to return a loading screen. Otherwise, if the user object is not null, that means that the user is logged in. For example, I can display a welcome message. But what I actually really want to do is reroute them to the dashboard. So I'll import NextJS useRouter here and redirect the signed in users to the dashboard like this. If I go back to my site, I've been redirected to the dashboard since I'm already signed in. If I try to go back to the index page, it will keep redirecting me back to the dashboard. So next, let's implement this sign out feature so we can actually go back to the index page. To sign out with Firebase, let's first go to our dashboard.txx file. We have to do this import Firebase get auth object to our page just like we did with the index. And then let's create an instance of the auth client. And this client conveniently gives us a helper function that we can use to sign out. So let's just attach this to our sign out button. If we want the site to navigate us back to the index, we'll also have to add a user hook like we did earlier in the index page to detect and possibly reroute us based on our authentication state. Now my page is broken because I made a silly mistake here. The error message is rendered fewer hooks than expected. And this is simply because I've returned this loading page before I called my useEffect hook to generate the store items. Next.js doesn't like us doing this, so if we want to use hooks, we have to call them all together and never change the number of hooks or the order of hooks that we are calling. So we just have to move things around so that the hooks are rendered at the top of the component before we do any branching return logic. Once that's fixed, we can test our sign-in flow and confirm that the site is working as expected. Now that we have a signed-in user, how do we use that with a custom API like the one that we have in this project? Our API backend is a Python program that is hosted on AWS Lambda. It has no connection to the Firebase Authentication server, so we need a way to authenticate requests coming into it. We're going to do that by attaching something called a JSON Web Token, or JWT for short, to our request. First, let's create an async function that we're going to use to call the external API. I'll then attach it to this add item button here. We can get this token from our user by doing this. Const token equals await user.getID token. Now let's console log it and see what happens when we call this function. Go back to the site and open the console in the browser. Click add item and you should see a really long string like this in the output. This is a JSON Web Token, or JWT. Now, before we continue with the app, I want to take a moment to explain JWT, because this is a really important concept to understand. JWT is an open standard, and it is adopted by many authentication providers like Firebase, but also other ones such as Auth0, AWS Cognito, and Fusion Auth. And even though the token produced from our apps looks like gibberish, we can actually decode its contents quite easily. First, copy the token from the console. Now open your browser and go to jwt.io and put your content in there to see for yourself. On the right-hand side panel, you can see all of the information that was encoded into the token. All of this information is public, and it has three distinct parts. The header, which contains metadata about the token, like what encryption algorithm was used to sign it. The payload, or sometimes called claims, which is publicly visible information that we can attach to the token. This is typically things like the user's ID, the expiry date of the token, and who is the issuer of the token. Finally, the signature, which is the cryptographic proof of the token's validity and integrity. If someone tries to change the contents of the token, the signature will become invalid. So how exactly do we verify this token? Well, if you've worked with SSL or asymmetric encryption before, you might already know the answer to that question. Otherwise, here's a quick summary. The contents of this message was signed by Firebase's authentication service with a private key. This creates something called a signature, this string here. If the message content changes or the private key changes, then it will produce a different signature. Our API doesn't have a copy of the private key. Instead, we needed to give it something called the public key. This key is still mathematically linked in a one-to-one relationship with the private key, and Firebase will happily provide this public key to us if we want to do this verification. This key will allow us to validate if the signature of the token matches the claims. So that means once Firebase produces and signs this token for our user, no one can modify it without corrupting the signature, and no one can re-sign it either without the matching private key. However, if an attacker finds an exact copy of this token, they can use it to make requests on the user's behalf. That's why tokens usually have a short-lived expiry date to minimize the window of attack. So now that we know roughly how the token works, let's go back and add it to our request. I've set up a public API endpoint for you to use, and you can call this directly from your project. If you successfully attach a token to the request, it'll decode the contents of the token and echo it back to you. And the endpoint is https jwt-echo.pixegami.io. To add a JWT token to an API request, we typically put it in the HTTP authorization header. So let's create a request object to contain that information. And here we'll have to format it like this. It's just a string with the word bearer, and then a space, and then the contents of that token. And now we can make a fetch call to that HTTP endpoint with our request object. Let's also log the response. Now back on the site, when we click this add item button again, we should get a response back from the API with the decoded contents of the token. This confirms to us that we've successfully attached the JWT token to this request header. This endpoint, however, doesn't do anything to verify that the token is valid. It just echoes back the decoded content. I do have another API endpoint that can also verify the token, but there's two things that it will need from us. First is the audience of the token, which is a string. And second is a public key that we can use to verify the signature. Normally, this information should be kept server-side, but because this is a development API, both of these fields will be parameters that we can send together with the request. So how do we know what values we need to send? Well, let's take a look at Firebase's documentation again. There's a page here called Verify ID Tokens, which contains all of the instructions we need. One way to do it is with a Firebase SDK, which we can install as a part of our backend API. But let's say we don't have that. Then our other option is to use a third-party JWT library, which is what we're doing here. Now back in our project, let's create stubs for our API call. We'll need a certificate, an audience, and a new endpoint. And this time, my verification endpoint that I've prepared for you is similar to the echo endpoint earlier, except we do /verify and then pass in the audience and certificate as query parameters. Now let's start filling in these. Getting the audience is easy. That's actually already in our token payload. Just open up jwt.io again and copy the value of AUD, which is short for audience here. This should be the name of your Firebase project. Mine is Pixegami Online Store. To obtain the public key for Firebase's JWT tokens, we can follow the instructions in the documentation, which is to go to this URL here and find the certificate matching our key ID. Again, our key ID is visible as part of the token header, so just copy that and look for it here. Mine is this top one, so I'm going to copy that entire string and paste it into my code. And because the string is really long and has some weird characters in it, I'm also going to use a function called encoded URI component to convert it into an HTTP-friendly format, so my backend interprets it as a single string, and not as separate routes or anything unexpected like that. And if I go back to my site and click this again, we should see a response that the token was successfully verified. So once your token has been verified, your API code will know whether this request is valid or not, and which user ID this request is associated with. You can normally find this information in the payload with a key named sub, and here sub is short for subject. From there, your backend can decide what to do with the request and what information, such as which database rows, this request will have access to. Also, just to show you, if I make changes to the audience or the token signature, their verification will fail. And again, remember that the audience and the public key are not normally sent as part of the request, because that would defeat the purpose of the verification. Instead, those two things should be known in advance by the API, maybe hard-coded or as an environment variable. Only the token is sent with the request and will be verified against the known public key and audience. Congratulations! If you've made it this far, then you've successfully added Firebase Authentication to your app. Here's a quick recap on what we looked at today. JSON Web Tokens is a widely adopted standard for authenticating API calls. Tokens can be verified if you have a public key, which should be made available to your API service somehow. Token payload is really useful for transmitting content such as the user's ID, but all of the payload is actually publicly decodable information, so you shouldn't put anything confidential in there. And finally, Firebase is one of the many authentication services and providers out there, but the high-level strategy is pretty much the same between each of them, so you can decide which one is right for you. If you have any questions or need help with anything, then let me know in the comments. Otherwise, I hope this was useful, and thank you for watching.